Welcome guys, this is a very quick video over bond polarity. So bond polarity is going to determine how equal the sharing is between two atoms. So you can see that there are three possibilities. If you've ever had a sibling and you've ever had to share a toy, or maybe you've shared toys or something with a friend, you know it's pretty rare for any sort of sharing to be equal. But if there is equal sharing of the electrons where, like this picture on the left here shows that the electrons are spending about the same amount of time around each nucleus. If that's the case, that's called a nonpolar covalent bond. They're sharing the electrons, and it's nonpolar because they're equally shared. If something is polar, remember we're talking about bonds specifically, that means that one of those atoms is pulling on the electron a little bit harder than the other. So that electron is spending more time around one atom than the other, so we're going to have a partial negative and a partial positive. So there are going to be poles or ends. This molecule, the charge is equally distributed. There's no difference between the two ends. Over here, there is a difference, so that's why we call it polar. Just like the planet has poles, this has poles. One end is negative, one end is positive. And then last but not least is an ionic, and that's not sharing at all, right? So that they're trading those electrons from the metal to the nonmetal. So we're seeing a huge distribution in the negative and positive charge. So this momentary partial charge is called a dipole. Could be called a dipole moment. So you see that the arrows can show the dipoles. We will use these sigmas a lot. And that's the notation that I want you to continue getting used to using is sigma plus, sigma minus, partial plus, partial minus. So that's bond polarity. We'll cover molecular polarity in a POGL and in greater detail later.